right? So today's topic for the presentation is learning under dataset shift and transfer learning. So this is one of my area of research where I worked for a number of years, including my PhD and my postdoc. So, so first of all, I would like to take you through this GitHub. So this is the link of my GitHub where you can find most of the codes, means my current research and my past research, what I'm doing. So my codes are mostly open source. And if you see any of my paper and you want my code or my help, you can email me. But most of the thing you can find on my GitHub, and my handle is Haider. Go and find clone repository, play with the codes. If you have any question, feel free to email me. Now, the outline of the talk. I have divided my talk into 2 sessions. We'll try to complete both. And by the end of the session 2, we'll have a kind of a practical demo also. So I'll try to finish it on the time. But first session is about talking about shifts in the data and what are the types, what are the causes of the shift in the data. And then if there is a shift in the data, then how to adapt to the shift using transfer learning or using domain adaptation. And for each session, we have a question and answer break. So where I can take your questions, but if you want to interrupt me or if you want to ask me any question, feel free to unmute yourself and ask any question. So let's start. So by starting, I would like to, because it's going to be a little bit mathematics, which I need to introduce you. So those means the points which I want to show you is a set of a feature or an input. Whatever we give into a machine learning model, we call it as a feature or a covariate, which is represented by X. We have a target variable. So for each supervised data, we have X, and then we have a target variable. Sometimes we call it a variable Y. So we call this class variable also. And when we represent this covariates and the class variable together, it's called a joint distribution, which can be represented like this. And in a problem where we have an input X and we want to predict Y. So using the value of X, we want to determine or predict the value of Y. This type of problems is known as predictive modeling, or you can say predictive models. Example are credit cards, fraud detection, and the machine learning model basically used for these are logistic regression, support vector machines, neural networks, and etc. And we have other type of models where we have Y and we want to determine the value of X. So that means you have a class or a target variable and you want to determine the value of X. This type of problems generally occur when you have basically your means medical type of data, or means when you want to diagnose some kind of problem. This type of model are generally applicable over there, and these are known as generative models. In neural networks nowadays, we are seeing that using the data, we are creating more data using generative models such as generative adversarial neural networks, GAN, like these type of things, where we generate the data. So this type of models are known as generative models. And when we represent data in the form of a joint distribution, we can write the problem in 2 forms. If we are using X to predict Y, problem can be written like this. And if we are using generative models where we are determining X with the help of Y, then the problem can be written as this. Now, other 2 points which need to be discussed, that whenever we do machine learning, we have form of a data where we divide the data in 2 parts, maybe, or 2 or 3 parts. Sometimes we only divide the data in training distribution and validation distribution, but sometimes we divide our data into training, validation, and test, and sometimes only test and training and test. So what we did, so we have represented our training distribution, data distribution, with the help of this symbol, PTR, and PTS is for the testing distribution. So these are some notations which we are going to use in the talk. So it's better to clarify before. So issues with the data in machine learning. So what is the first issue in the data in the machine learning is imbalanced data set. So in most of the problems you see, whenever you get data, you get imbalance in the data. For example, if any data coming from medical industry or maybe any real world industry, it's a high, I mean, the chances are very high that the data is going to be imbalanced. Imbalance means, for example, uh, class A and class B are there in the data. And what happened that you can see the light blue color is dominating over the purple color. That means the ratio of light blue class A is dominating class B. So it's very difficult to learn this type of data, or you can say if you learn this type of data without balancing it, you are biasing your machine learning model. So right, for example, you are giving emphasis on one type of data more rather than other type of data. Second issue is overlapping data sets. So what happened? So you see when you get your data, and initially when you get any data from anywhere, what you do, firstly, you do analysis of the data. So what you do plots, you do histograms, you do different type of plots. So for example, when you plot the data into a scatter plot or something using two variables, if it is a bivariate data. So what you do, you see that black dots and red dots are overlapping each other. So it's very difficult to draw a line to separate two classes. So for example, if black is class A and red is class B, so it's very, very difficult to separate this data, right? So what we need to do, we need to transform this data into some feature space where this data becomes separable and do such type of thing. So overlapping data set is another challenge in machine learning. We have to deal with it. Another type of issue is density, the lack of data. So for example, you started trying to solve a problem, for example, and what is happening, the amount of data you require to learn a model it's not sufficient. So what will happen, you won't able to form a kind of distribution. So you don't have sufficient knowledge to give the answer. So it's very difficult to learn from less data, right? So the more data you have, the better distribution you can fit. But if you have less data, it would be very difficult for us or for you to fit a good model, right? Now, the second is noise in the data. So you can see when we have data, when we are acquiring data, we got a lot of noise in from the data. For example, my background is brain-computer interfacing. So what we do, we record the data through brain. So what happens when we record the data through EEG electrodes, along with the information, it comes with a lot of noise, right? So we have to clean those noise. So for example, if red curve, you can see, this is our information. You can see the blue dots coming with it. So you never find a smooth line. You always you always find information that come with other information. So we have to separate the noise from the data. For example, if you get any data from any sensors, it is highly subjectable that the data is coming with noise, right? So if any image you click, right, that image, the information within the image is very limited. It's come with a noise also. So we have to get rid of this noise, because the more the noise is, the chances of overfitting your model is high. Because if we are going to use some advanced machine learning models, what we are going to do, we are going to fit the data where we are going to fit the, we are going to learn the noise as well in the data, right? So we have to avoid that. And another issue which I used to work is called dataset shift. And dataset shift is what? So for example, you have a training distribution, you have a test distribution. And in this training distribution, you can see it's a blue Gaussian. And for example, this is my training distribution. And over here in my training distribution, the first half is class 1, the second half is class 2, right? So what will happen in this class 1 and class 2? So for example, if this is class 1 and this is class 2, we can draw a decision boundary over here in the middle, right? But whenever we are getting the test data, you can see the mean of the training data and the mean of the test data is not equal. So maybe the class 1 is over here and class 2 is over here. So what we have learned this in the data, and what we want to classify this. So definitely your model is not going to perform well, and this type of a problem is known as dataset shift. So why we are discussing this? So let's create a motivation behind it. So in learning theory, independent and identical distributed assumption. So what we made, whenever we record some data or we get the data, we assume that data is following IID assumption. What it means that each random variable have a same probability distribution as other, and all are mutually independent. That means the data which we are getting are coming from some kind of they are random variables basically, right? And they are all mutually independent, right? So other point which we make when we record the data, that in practice what happens, the train and test distribution have a different training and test inputs have a different distribution. So I have discussed you before also that whenever we get the data, for example, we are getting the stock data, any stock market data, right, in day 1 or day 2 or day 3, we recorded the data for 1 month and we trained a machine learning model, right? And when we train a machine learning model, when we have deployed it somewhere and when we are going to use it, for example, if we have recorded the data in May, right, and we are trained it and we are going to use in June or July or August, the data is coming from the same source, but the properties or the associated variables with this may change the distribution of our data, and the data will change the shape. So this will happen in real scenario, right? So the difference in distribution arises for operating in non-stationary environment in real world applications such as finance, healthcare, brain signals, and much more. So learning such non-stationary environment is difficult, and we need to think. So for example, whenever you get data in real world environment, the data is coming from non-stationary environment. Basically, nothing remains the same. The health condition changes, the weather changes if it is coming from sensors, right? And if you are recording the stock data, purchasing behavior of a person change, market change, everything's changed, So whatever the data you get in real time, all of the data having some form of non-stationarity into it. So that means the data hardly remains stationary if you record it one day or at different time. So now this is the motivation. So what happens that if this problem is there, what will happen that the model you learned will not work in day 2, or for example, whatever you have learned for your training distribution will not able to work in your test data. You will not go. So for example, if you are getting a training accuracy of 90%, there is a high chance that you won't able to get 90% of accuracy in test data because the data distribution changes. So for example, if this type of conditions happen, then how you are going to work, how you are going to learn from the data. So we are going to discuss dataset shift, type of dataset shift, and causes of data shift, right? So what is dataset shift? So this dataset shift is defined by a lot of people. Before 2009, it was known by different names. So what is dataset shift? Dataset shift is a condition where joint distribution of input and output differs between training and test stages. So I hope you remember in my notation slide, I have written P bracket X comma Y, that is my joint distribution, right? So if that distribution between training data and test data changes, then that is the condition of dataset shift, right? And before 2009, people know that dataset shift by different names. For example, consist shift or drift. In 2003, people said data change of classification. In 2008, people say changing environment. 2009, very famous guy Chawla, he said fracture point. So means where the data change, they say it's a fracture point. And in 2010, people said it fracture between the data. But since 2009 afterwards, means people try to avoid using different names. So a new name came called dataset shift, and we are trying to stick with this name only, right? So let's discuss further. So I have already given you example. So one more example for that, how dataset shift happens. So for example, in speech recognition system, you bought a car in Australia, right? Example. And in Australia, you when you bought a car and you first insert the key, what happened? You switch it on, and because that car is voice enabled, so for example, you handle your GPS or any kind of thing with your voice. So what you have, it's asked you to set several sentences, for example, to read a paragraph or something, and you read it, right? It's working fine in Australia, right? But when the same system came here in India or maybe in UK, right? So for example, in Australia, somebody said, drive me to XYZ postcode, right? But when it came to UK or India or US, the accent changed, and I said, drive me to this postcode. So, but what happened when we trained the system? When we trained it, the amplitude, the phase, other properties of the voice is different, but here the voice is different, right? So because we have trained our machine over there, and if we are going to test or use that machine over here, right, what will happen? It won't able to understand what you are trying to say. So for example, when you buy a new iPhone or maybe a new anything, it asks you to say several sentences, say hey Siri or hey something, right? Or hey Alexa. So when you buy something, you train your machine that this is my voice, try to understand it. If a new person comes to your house, they say hey Alexa. Alexa can understand, but if the voice is matched, if the voice is not matching, Alexa or Siri can't understand that. Why? Because there is a problem of a data set shift. So on what you have trained your data is not same, right? So we have to understand this data set shift. So how to avoid this type of shift? Because what we are trying to do, we are trying to build a machine as smart as possible, right? So we want to build machine learning models which can avoid this type of problem. So for example, if I train a machine, my friend can use it. I want to build this type of machine, right? So let's see. So I have already told you data shift appears in training and test. Joint distribution are different. That is when the probability in the joint distribution is different in training, and the joint distribution in test is different. So they are unequal. So you can see if this is your training distribution, it's looking different over here. And over here, you can see the pink crosses are dominating over the green. So the distribution, the joint distribution between training data and test data different, right? So basic assumption for classification operating stationary environment is this. So before this data set shift, what happens? We have a training data. We build a classifier. We get a good validation accuracy over here. We are saying we are achieving 99% or something. If the data set between this and this remains the same, you will get good accuracy in your test data. But if this training data is different from this test data, you are having a chances of getting good training or validation accuracy because your data is coming from the same sample. But if the data sample is coming from different distribution, you will get an inaccurate class prediction just because of this data set shift. Or classifier has overfitting the problem, or you have learned something different, right? So now the problem of data set shift. So how you can solve this problem? So can I ask my participants to just, if anybody have an answer, that how you can avoid this problem? Anyone have any answer?
Maybe don't be too specific.
Yeah, sorry. Go ahead.
I'm Manan, and I think if we train the model with specific things, it won't work in general. So it's better to have variety of trainings.
Okay. And what else? Anything else?
One answer. Maybe some other participants can answer.
Hmm? Train the model with all the data set possible. So I'm getting the answer from Dr. U. Srinavasu, right? So uh, uh, you are saying train the model with all the data set may possible. Yeah, but getting all the data set is pretty difficult, means acquiring all the data set at the same time is pretty difficult. Yes, sorry. So any other answer? Okay, so see, there are several scenarios by which we can solve this problem. So if the classifier has overfitting the problem, so overfitting means you are unnecessary making your model complex. So for example, you are trying to fit the data with a mathematical equation, and that mathematical equation, you are unnecessarily adding more parameters to that model. And what is happening, uh, you are trying to learn the noise in the data, which is not needed, because what we need to learn the information in the data, not the noise, right? So what is the possible solutions? Possible solution is change the parameter of the algorithm or use a more journal learning method, right? These are the classical solution. But if there is a change in the data distribution between training and test, then what will be the possible actions? Possible action is, so for example, your training and test distribution is different. So the solution will be train a new classifier for the test dataset. But that solution is not feasible, like I generally don't recommend this solution. Second solution will be adapt to the classifier. Adaptation to the classifier is okay, so but how you are going to adapt? You need a kind of an you need a kind of adaptive learning algorithm, right? So where you learn by changing your parameters over time, right? I can see one answer from Siddhant Singh, and he's saying maybe cross validation may help. Yeah, cross validation may help, but what cross validation can help you? Because what when you do cross validation, you have a training data, you split your data into 10 parts, right? And if you are doing tenfold cross validation, but still you are taking the samples from the same distribution. But in dataset shift, you have two distributions. One is training distribution and one is test distribution. So training and test distribution are different. They are not overlapping. But if you do cross validation, you are going to sample the data from the training distribution itself. So although you are taking slightly different distribution, but still it is coming from the same population, right? So means that is not a solution but a remedy to prevent something, right? So second part is to modify the data set in the test set to, so for example, what will happen, what I have means gone through the literature and what a lot of people did. So for example, you have a training data and you have a test data, right? So what they did, they so if you plot the training data and if you plot the test data, you see that they are different. So what they do some kind of a transformation on the test data, so the overlap between the trained data and the test data will be minimized, right? So for example, if I share you something, one second. So if I share you my different screen, maybe a whiteboard. Can you see a whiteboard? Yes. So for example, this is my training distribution. This is my test distribution, right? And what is happening now, what people do, if this is my training distribution, this is my test distribution, what we do, we use some kind of transformation to minimize this gap, right? And what I have gone through in the literature, people have used a method called importance, right? So those guys who understand, or those who are from the statistics background, so calculating the importance is a kind of a method by which you take you calculate the importance by taking the ratio of the distribution of testing data and the training data, right? And once you get that importance, if you multiply that importance with your test data, what you are going to do, you are going to minimize the gap. But there is one drawback. There is one drawback in that method, and the drawback is that, so for example, if you are working in a real world environment, you have your training data. So I have my training data, right? And I don't have my test data. So I have to learn a model called F from this, right? I have to learn a model from F called F. But if I don't have my test data, because I'm going to get my test data in a real world settings, so if I don't have my test data, how I'm going to calculate my F? So how I'm going to calculate my importance, right? So that means this particular type of methods, by calculating the importance, or people call it density ratio estimation. So that is only applicable when you have your test data and your train data in hand before, right? So that means this type of importance or density ratio estimation type of methods, they are not applicable in online settings. They are only applicable in offline settings when you have an offline data with you. So coming back to the point, so we'll see how to solve this as we progress to the lectures now. So dataset shift, I have already told you, people have called it by different names, so that's the same slide. So I have discussed what is dataset shift. So now you guys have understanding what is this dataset shift. Now discuss what are the types of dataset shift, right? So types of dataset shift, generally there are three different types of dataset shift. First is called covariate shift, second is called prior probability shift, and third is called concept shift, right? So in covariate shift basically happens when you are working on predictive modeling. Predictive modeling means you are having X and you want to predict Y. So that means you have an input and you want to predict the target variable Y, right? So what is the condition for covariate shift? In covariate shift, the conditional distribution between the training data and the test data remains the same, but the input changes. So for example, means this is the mathematics, but what I want to say you, so for example, you have a training data of anything, for example, a weather data, or maybe a forest fire data, right? So you have a forest fire data, which is this X, right? And you have learned that data and you got an equation, and the model which you have learned is represented by this. You are taking the same model to the test distribution over here, nothing has changed. But the data which you have learned over here, that means X without Y, it's from January to May. And the test data is from June to December, right? So in June to December, there is a high chance of a rain. So that means if you plot these two different data, they're going to be different in the distribution. So for example, if you see this training distribution is over here, the test distribution is over here on the left hand side figure. So this is your covariate shift. So that means only the input is changing. We are not changing the conditional distribution of the data. We are only changing the input. So that means the input, the covariates which we are getting to our model, their distribution is changing between training and test data, right? Now, if we have a bivariate, so that means if we have two variables in the data, so for example, we have temperature and a humidity, right? So if we have a temperature and a humidity, so if we are doing some kind of classification, so you see the blue ellipse over here, we have two blue ellipses, one blue ellipse with circles and one blue ellipse with the stars, right? So this blue circle is class 1, this blue circle is class 2. And if we want to learn anything, what we are going to learn, we are going to learn a hyperplane between these two blue ellipses. But when we get the data for test distribution, right, we have this blue ellipse over here, we have this this red ellipse over here, and we need a hyperplane from here, which can classify the problem, right? So we can clearly see the distribution. Although this is just a synthetic data, I can show you on the real world data also. I will show later in the slides what we have validated, but this is how you check whether your data have a covariate shift or not. So if you have a univariate, if you want to check a single variable, just plot a histogram, fit your data over there and see whether the training and test distribution are different or not. Or if you have a bivariate or multivariate data, take two variables at a time and plot a scatter plot or something and check whether your data is suffering from covariate shift or not, right? So this covariate shift was defined in 2000, nearly 20 years ago, and means before that it is coming with different names, right? And if you see, covariate shift can happen in both problems, whether it's a classification or a regression. So if it's a regression problem, what we can see in our regression problems, we have these blue dots, and I want to fit a model on this blue dot. So how I'm going to fit the model? So what I need, so what I can get, so I need to fit like a line like this, and this blue dots is my training data and black dot is my test data, right? So what I did when I was training, I fit with this green line on the left corner. Can we use this green line to predict this black points? No, it is not possible. Why? Because what we have learned like this, and if we want to predict, or if we want to fit with the black points, we need a line such as which is given in the right hand side, right? So this is how you check covariate shift. So you have learned this and you are trying to predict this. How you can do that? It is not possible. So that means it is a covariate shift in a regression problem. Similarly, in classification, so this is one of the data set, which is a brain data set. And when I was doing my PhD, I was analyzing the data. And what I found, because I was dealing with this covariate shift, so I took the brain signals data and used the EEG. And what I did, I plotted both training and test data. So you can see the blue ellipses, right? Blue ellipses, left ellipse is a class 1 and right ellipse is class 2, right? And what we have learned is the black hyperplane. But when I plotted my test data, which is red ellipses, you can see the hyperplane which is required to classify this data is this red dot. And we are trying to classify with this black line. So that means definitely if we are getting a training accuracy of 70 or 80%, the test accuracy will definitely come less than 60% because we are shifting in the data. So if you see in another data, means same subject data, but in different settings, see what we have learned this black hyperplane and we are trying to classify this red hyperplane. So that means whatever the data is lying between red and black hyperplane, it's going to be classified wrong, right? So, and if you want to read more, you can see my citation at the bottom, my reference, and you can read in detail about this, right? Other type of a shift is known as prior probability shift. So in covariate shift, what we have, the covariate shift is applicable for predictive modeling, but in prior probability shift, when we are using generative models, this type of model can be suffer for prior probability shift. So what happens? The equations remains nearly same at the top, that the conditional distribution between the training and test distributions remains the same, but the prior distribution of the data changes. In covariate shift, this y was x, but in prior probability shift, this is y. Why? Because when we are learning a model, class A is 50%, class B is 50%. When we are doing or validating or testing the model, our class A is dominating over the class B, right? So this type of a problem is known as prior probability shift, and still means now the research is going. I can see a lot of paper now are coming how to handle this prior probability shift and concept shift. covariate shift. Now, so you can see, if I explain you in more details, so you can see this is the distribution. So you can see the distribution of a PTR is 0, of class 1 and class 2 is 50%, 50%. So we have plotted in training, it is 50% and 50%. And when we are doing in testing, the distribution of a class 0 is 70%. The distribution of a class 1 is 30%. So that means the ratio is 30:70, right? So see, the distribution changes, right? So if you have this type of problem, that means if your data is having this type of problem, so that means you are suffering from prior probability shift and your model is going to give you biased answer. So before learning, we have to think. The last type of a shift which we have is called concept shift. And in concept shift, what we have the data. So that means the input which is coming to the model, the covariates which is coming to the model. So if you are doing a predictive modeling, the covariates which are coming to your models remains the same, but the conditional distribution changes, right? And if your model is generative model, the conditional distributions changes, but the prior probability remains the same. If this type of problem is happening, then your problem is suffering from concept shift. So now in general, what I would like to say to you, that for example, if your training model, if your data which you have learned, that data and on which you are evaluating your model remains the same. So for example, if you remember what I have said earlier in the lecture, that you have got a speech recognition model, you trained in Australia and you are testing it in US or UK, it's not going to perform well. But here in concept shift, your Australian data is same as Australian data, but the model which you have trained in Australia not remains the same when you are testing. So that means the equation, the parameters, the weights which you have learned in the model have changed. So that means your model distribution has changed. So that means you have to relearn the model again, right? So this type of a problem is known as concept shift. So dataset shift divided into 3 different parts: covariate shift, prior probability shift, and concept shift. Any question, guys? I'm open to question now. If you would like to give some questions, please. Anyone? Any question?
Hey, Heather, this is Manu.
Hi, yeah.
So initially you talked about noise in the plot, right?
Yeah.
So I have a doubt. Like it's a, let's say that it's a scatter plot. Then how can we define a noise, and which is the exact pattern we need to take, and which is the scatter?
For example, if your data is having a noise, your first job is to clean the noise from the data. So the plots which I have shown you, those are the features which are ready to be fed into a classifier. It's not a features or not a data on a raw data. So first you clean your data to get the features. So always, so for example, before you feed anything to your model, so for example, when you are learning anything, so always check concept shift after, any type of a data set shift once you pre-process the data. Because if there is a noise in the data, definitely your model will show some form of a shift in the data. So once you do pre-processing, you clean your data, you think that you have done your best to clean it, then check whether your data is suffering in some form of shift or not. Have I answered you?
So that cleaning part or pre-processing part is what we are reducing the noise, right?
Yes. So for example, when you buy fruit or when we go to the grocery or anything, once we buy things, we have to clean it, So before we cook, we clean the things, we cut the vegetables, then we cook it, right? So same as the classifier, because what you are learning, you learn, before you learn thing, you have to clean the thing. Because if you don't clean, you are going to learn the noise, right? But your model, which you are going to learn, you have to think. So for example, when you are learning something, so you are learning your model, your data, and when you learn your data, you are going to learn some kind of information from it, right? Some kind of features from it. So best way to check, or best position to check a data set shift is when you clean your data, not before cleaning. Because if you do before cleaning, you will definitely form some kind of a shift in the data.
All right. Yeah. Thanks. Thank you.
Any other question? Strong room here. Okay. So let's move forward. So there are main two causes of a data set shift. One is known as sample selection bias, and other one is known as non-stationary environment, right? So sample selection bias, sample selection is bias is a process, is a term which is related to when you acquire some data, and when you introduce some kind of discrepancy in the acquisition of a data or obtaining the data through a bias method, that is known as sample selection bias. So when you are collecting the data, you are not taking care of all the parameters, right? So for example, when you are taking out the data from some sample, you took data from somewhere which is not balanced. So that means your data is suffering from sample selection bias. So for example, if I am gathering the global data, I only gather data from US. I didn't get data from UK. I didn't get data from India. I didn't get data from China. And I'm going to design a vaccine or a kind of thing for a coronavirus kind of thing, right? But I'm only considering the population of US because I'm designing the drug over there. But if I'm not considering that drug for Indian people or for Chinese people or for Africans, what is doing? I'm doing sample selection bias. I'm suffering from sample selection bias because I am biasing my model to only work for this type of data, not for other type of data, right? So if you obtain the data and you are suffering from sample selection bias, you are going to suffer from data set shift. This is what I want to say, right? And non-stationary environment, it appears when the training environment is different from the test one. Definitely why that happened? Because your data is coming from non-stationary environment, and that can be happened due to temporal change or a spatial change in the data or due to any conditions. So right, so means there are several conditions by which what is the reason of non-stationary environment, why your data is changing? Because the time is different, the space is different. There are several reasons behind that, right? So this is what sample selection bias is. I have already told you. So I will upload my slides. If you want to have a look later, you can look. And what people think that if you do cross validation, so I can see in my chat somebody said use cross validation to avoid this, right? But so this is what cross validation is. You divide your samples, you divide into different parts, and then you do cross validation. But if your data is suffering from covariate shift, the cross validation will also not work. So that's what people said, that cross validation is heavily biased under covariate shift. If your data is suffering from covariate shift, there is no use of cross validation. Cross validation is biased under the covariate shift, right? So this is what we have over here. So any other question, guys? Okay, so let's move forward. So you have seen now what are those shifts, what are the shift in the data, how to handle the shift is now what we are going to consider, right? So we have discussed the shift. Now learning in non-stationary environment, why learning is important and why under non-stationary environments. So this is a very good paper which published in 2015, and it was published in IEEE Computational Intelligence magazine. And this is one of the graph, or you can say one of the plot, which says learning in non-stationary environment, how you can tackle it. So whatever the data you are getting, so I'm sure a lot of you are doing PhD, a lot of you are doing your master thesis, a lot are doing research. Your data is suffering in any form of non-stationarity into it. Any form of dataset shift will be there in your data. So how to see what to do, right? So how it can be possible? So if you are doing learning modalities, online learning is possible, incremental learning is possible, supervised learning, drift detection. So these are the area you can work. So a lot of people are working in different area. If your PhD or your research is in model adaptation, you can consider active approach or passive approach. I did this. If you are working in deep learning area or maybe neural networks area or any kind of area which is related to shift or knowledge representation, you can work on this covariate shift. You can work on domain adaptation, developing new methods for domain adaptation, or developing new methods for transfer learning, right? Applications for this is where this learning in non-stationary environment can work: electrical load, spam filtering, sensor network, brain computer interfacing, health data, weather data. So whatever the data is coming in real time, this is applicable to all of them. Wherever you are getting the big data, your big data is suffering from non-stationary environment. So you have to deal with non-stationarity. So if you are doing any of the tasks, you have to think how to handle this problem, right? So as I have mentioned you, I worked on this area, so I'm going to little bit cover this much, this area for you. So a very basic thing, I want your answer, guys, if you have an answer for it. So model adaptation is what? What is model adaptation? Model adaptation is that the data is going to change, and if the data is going to change, your generalization performance is going to decrease, right? And if your generalization performance is going to decrease, you won't be able to perform better, right? So in that scenario, there are two ways to handle the shift. There is passive approach and there is an active approach. So passive approach says continuously update the model over time without acquiring and explicitly detecting the change. An active approach is saying detect something and then take the action. So passive action and active action, right? Passive action says don't think, just adapt every time. And active says don't adapt every time. When something change happened, then do adaptation, right? So getting my point is says like that. So for example, consider two type of people are there. One person take medicine every day, or maybe you can say immunity boosting type of tablets, because he want to keep his body updated every time. That is passive approach, that I don't want to get sick, I want to keep my immunity high, I fast, I run, and I take some kind of multivitamins or any kind of tablets, right? But there are other type of people who only take medicine when they get sick, right? Or when they feel that they are weak, right? So for example, that I am going to take multivitamin when I feel that I am low, right? So these are these two approaches, passive approaches and active approaches. In passive approach, I assume that the data is coming from non-stationary environment, and when the data is coming from non-stationary environment, I assume that data is changing every day. So what I do every morning, I'll retrain my classifier on the new data. I'm storing my data and I'm retraining my classifier every day, or every patch of data, when a new patch will come, I'm going to retrain the model. And in active approach, what I did, I have included a kind of a test detection model. So in active approach, I'm going to introduce a new component in my machine learning model. That new component will detect the change in the data. That means the data which is coming to my model is going to detect the change in the distribution. Distribution means the standard deviation or a mean if the data is normal distribution. So for example, if you are monitoring your normal distribution data, it has a mean and it has a standard deviation. And for every population or every sample of data which is coming to me, I'm calculating what is the mean of my data and what is my standard deviation. If this mean and standard deviation change over time, that means the data is coming from different distribution. I have to adapt, right? So these are the two ways of adapting. What are the advantages and disadvantages? So don't use shift detection test. What is passive approach? Passive approach don't use any form of shift detection. It continuously update the model. What is the advantages? It always up to date all the times, and avoid the pitfall associated with active approach. That so what happens in shift detection models when people use active approach? So for example, the component, the test model which you have introduced, the change detection model you have introduced in your model, what it's going to happen, it's going to detect the changes in the data. But what happens if it's not going to detect the change, or it falsely detect a change in your data? So then that means that you are unnecessarily going to adapt to your model, right? So in passive approach, we have no such thing that we are going to falsely detect the change, or they're going to be false positive or false negatives. So there is no headache for that, right? But what is the disadvantage? Disadvantage, this type of models are that we have to rerun the model every time. Every time a new data comes, we have to rerun the model. We have to learn the model, which is not feasible. So for example, you have a deep learning model, which you have trained in 30 days or 20 days or 15 days, right? Every time a new data you get, are you going to retrain your model every day? Which is not possible, right? Every 30 days it is updating. So that means in 30 days we are retraining it. How is it possible that I'm going to update it? How is it possible I'm going to retrain it every day? So that means these type of models are not possible in real-time systems. But in active approach, sorry, in passive approach, there are two methods: single classifier and ensemble of classifier, right? So how people do single classification method. So you have a single classifier, and you are updating the knowledge every day, right? But in an ensemble classifier, what we do in passive approach, people learn multiple classifiers, and when they learn multiple classifiers, they are going to use their majority voting and some kind of information which can give you an expert answer. But what other people did in ensemble of classifier, so for example, when you are doing an ensembling method, what you do, so for example, I'm learning every day. So every time of a new data comes, I'm going to learn a new classifier. So for example, I have a knowledge of 30 days. When I have a new information of a 31st days, I'm going to add a new classifier into my ensemble, right? And there should be a threshold. So there is a lot of research on that whether this approach is good or not, because you are going to increase number of classifier in your ensemble, which is increasing day by day, and you are not discarding information. So it's going to be overloaded. So what is the best way? So people say, people are using approaches such as, I'm going to discard it after 30 days. So for example, there is a window. So every 30 days, when the model come on first day, after 30 days, that model will goes. In finance industry, people use this approach quite a lot, right? So if you see Yahoo Finance and those type of things, a lot of people are using this ensemble based approach, and they are using this particular window approach, that whenever my model will come, whenever new data will come, I'm going to learn a new model, and after 30 days, I'm going to discard it. But there are few drawbacks of it. Now, in active approach, I have told you already before that we have a classifier, we are getting the data from it, we are extracting the features from the data. What we did additionally, we are going to introduce a new point over here, which is called change detection. Your data is coming, you are extracting the features from the data, and before giving it to the classifier, you are passing your data through a change detection model. If the change detection is saying yes, then you are going to adapt the model. Otherwise, you are going to directly pass your data to the classifier to get the answer. And I did my PhD on this, that how this model is applicable in brain computer interfacing settings and whether this approach is useful. And we did trials, we recorded the data. I have implemented this approach online into a brain computer interfacing setting, and we have proved that this approach is better than passive approach, but there are few drawbacks which we will discuss later, right? So but the question is this: if you are going to use this approach, how you are going to decide which change detection is good for you? So there are a lot of change detection methods you can use according to your problem. I have designed my own change detection detection algorithm because that is the need of my problem. So there are so many change detection model. You can use any of them. Adaptation, there are several ways of adapting to the model. You can adapt it in supervised mode, you can adapt in unsupervised mode, you can adapt in semi-supervised mode, you can use in transduction approach. And the new learning adaptive models are Learn++, NSE, Compose, JIT, Adaptive. So if you want to see adaptive models, you can see it. You can Google it and you can find what are the new adaptive models. So yes, any questions, guys, till this point? No question, guys? I can see somebody is doing in chat. How to filter the data optimization through simulation tool? What does it mean? Umang, you are asking how to filter data optimization.
Can I speak, sir? Yeah. Actually, my point was when we talk about the data optimization technique, for that we use different types of algorithm. But as a beginner point of view, if we are going to guide the students, so should we prefer a specific simulator to understand them how to optimize the things, or we should go ahead with the algorithmic part?
So optimization is needed when you need to tune the parameter. Right. So but why? Optimization is only done when you have number of parameters to fit. Right. So I'm not able to connect what you are trying to say, because
my point was when we talk about the subject related to AI or ML, these are the subjects, they may be in the second year of the students, right? And when we are talking about the beginners, so a simulation or a visualization of optimization of a data for a beginner would be quite interactive or understood to them. So if I am talking about the beginners, sir, then rather than teaching to them related to the optimization technique and all, but we need to tell them how to optimize the things, and there is the requirement of data, because bulky of data is are there available there, right? And based on the requirement, we need to filter the data. Right. So as a beginner, if I need to guide to student, so can we use a specific simulation or a simulator by which we can say that look, this is the 10 student of 10 this is the result of 10 students, and now you need to optimize the thing where you are getting link up you can say concrete information, and where you are not getting the focused information or irrelevant information, sir?
See, the most important thing which I felt, because I teach to both masters and bachelor's.
Right.
So what I felt from my experience, that the most important part which we are trying to understand is this. I have attended yesterday's lecture as well. That don't just start learning the data. Right. So once you have a data, don't just put into a neural network or support vector machine or anywhere. first try to see what you are trying to answer, right? So for example, I have a data, right? And in that data, I want to find which means, for example, I have an image data, and in image data, I want to find 10 classes, which is cat, dog, elephant, this, etc., 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 right? So I got the images. Now my question is, I want to classify into different classes, right? So I just don't put my data into a neural network to learn. I want to first see whether all of my images are of equal size or not. All of my images are colored or black and white. How are the images are noisy or not? Right? So once I answer this question, or when we split the data, so for example, if you say you are going to have a data set of cats or maybe animals where you are going to learn, the data set which you are learning, the cats belongs to India maybe. And that model where you are going to test your cat data set, you are going to test the cats where the cat images are from Siberia or from Russia or from anywhere where the cats don't look like a cat, they look like a dog because they have furs. Right? So you have to first see and understand your data. That is, your data is suffering from any kind of a problem or not. So I would say to you that filtering is very, very, very important part of machine learning. If you don't do filtering, or you don't understand that what your data is and what is your problem, then blindly learning is not possible. And for example, see, once you filter your data, you start learning. And when you start learning, you have 10 parameters to fit. So for example, if you are doing neural network, you have a parameter that how many kernels you want to learn, what are going to be the number of epochs, which is going to be which activation function is good for you, right? Is dropout is good for you or not? So you have different parameters. Then optimization came, right? Then you have to check whether the optimization can help us or not. Then what you did, you put those parameters into a kind of a grid, and then you applied a grid search method that which set of parameters are good for you through optimization. Right?
Right, sir.
Getting my point?
Yes, sir.
So
yes, sir.
It's all step by step. It's not that it means I'm getting your point. What you're trying to say, that you want to show a student the importance of optimization, right?
Right.
But if you want to show the importance of optimization, first make sure your student understand what is filtering, why they are optimizing. Because people say, I want to learn optimization, but why you want to learn optimization if there is no use of optimization in your problem?
Yes.
Optimization only comes when you have number of parameters to fit, right? So you have a complex function to fit, but you don't know whether you are fitting it or not, right? Then the optimization came. Have I answered you?
Yes, sir. If we are having a bulky data, right? And if we are talking about the bulky data, and we are talking about the requirement of the data. So requirement of data should be suited with the availability based on that factor. So we need to filter out the information from the bulky data.
Means information, what type of information?
I am telling you. Sir, when we are talking about the proliferation of the technologies, so people are using a number of technologies, and they are transferring the information from one end to another end in the different types of formats. Either we are talking about the data or images or a video, audio, like that. But as per the requirement, we need to filter out the information based on our specific problem. Yes. So in that case, we would be having a requirement of filtration first, right? Yes. And after the filtration, we need to see that whatever the because we people are living in the heterogeneous environment, and we need to build up the application according to that scenario only. So we need to see that filtered part of data do we have a requirement of optimization if we are having specific limited
But
facilities with respect to
I'm not getting you why the optimization came here. So you just filter the data. So for
Hmm.
example, you have a very big data, right? Where you filtered according to your needs. So for example, I have a data where it has images, it has this, XYZ things, right? And I have to pick the data for two factors, which I need to filter it. I filter it, and when I filter the data, I get the filter data. Then how optimization came before learning? So optimization only came when you learn something. So when you have different parameters to fit, then optimization comes. I don't understand how optimization came before.
No. Optimization will come after that. But my question was, sir, can because you are saying that based on the factors we need to filter out the data, right?
Yes.
We do not have a requirement of a simulation, right? My
Yes.
question was only that do we go ahead with the simulation first or our data first? Then you told me that we need to go ahead with the data, we need to exercise on the data directly rather than moving to the simulation,
Yes,
right, sir?
definitely.
I
Yes.
got your answer, I got my answers.
Thank you. Thank you.
Thank you so much, sir. Thank you.
Any other question, guys? Shall we move forward? Okay. So now I'm coming to what we have covered. We have covered the dataset shift. I have explained you that what is dataset shift, that when you have different distribution. So people ask a lot of time, when you have different machine learning, you have supervised learning, you have unsupervised learning, you have reinforcement learning, you have transductive learning, you have semi-supervised learning. Why this new transfer learning came? Why Google and different companies such as Google, Microsoft, and they are coming with their pre-trained models, and why this transfer learning came? So answer is this, that we don't have a computational capability, or we don't have time or enough data to every time train a model from scratch, right? So for example, if you are doing computer vision, you are having a model or a data which you want to learn, right? So for that type of a data, what you don't have a sufficient information. So if you don't have sufficient information, it is very difficult to fit and learn from the data. So what these companies did, they used their computational power, they gathered the data from wherever they want. What they did, they trained different architecture of a models, and after days of a training, the weights they get from their model, they put it online in GitHub, so people can use their weights to learn their own data using their weights. So for example, what is happening is that when we use their weights, so weights is what? The information which they have learned on their data, they have shared with us. We are going to use their information which is similar to us in solving my problem. So for example, the transfer learning, or maybe the VGG16 data set, is trained on 1,000 different classes of images. So each layer of the deep neural network is responsible for extracting relevant information. So for example, first layer is for detecting edges, then different layer, more complex is coming. So what we did, we are going to use their knowledge of edges, that if this type of a pattern is coming in an image, that means this is the edge. And in my images, there are also edge. So I don't need to learn that information again, because that information has already been learned by those transfer learning models. So I'm going to use their weights into my model, and I will use their information or their knowledge for my problem to solve my problem, right? So see what transfer learning is. So traditional machine learning is this: we get the data, we learn the system. We get the data, we learn the system. But in transfer learning, they have the data, they learned it, and they kept it somewhere. Now we are taking their knowledge, adding my data over here, and combining them into a my learning system. So this information which they have shared with us is going to benefit us in implementing or spending less time to make a better performance, right? So transfer learning is a kind of a learning method where a model developed for a task is reused as the starting point for a model on a second but related task. So for example, knowledge gained while learning to recognize the car could apply when trying to recognize the buses, right? So for example, when your friend or your colleague have a database where they have different cars, they have learned a model, a deep learning model, and at the end, when they have trained their model, they have saved the weight in H5 file or any kind of file, any weights file. They kept it in somewhere on GitHub, wherever you want. What you did, you taken their weights, and when you are going to learn the buses or recognize the bus, what you did, you use their weights to classify your buses, because car and bus have a wheel. So the weight they have learned for the wheels, it's going to be useful for the buses. They have a window, car have a window. Structure, it's big and small is the difference. There are other differences also, but there are a lot of similarity between cars and buses, which can help a model to detect a bus from the data set which is being learned for the car. This is what transfer learning is. So in practice, people train a CNN from scratch, random initialization, because it is rare to get enough data set. But very deep networks are expensive to train, that take weeks and hundreds of GPUs to learn. So that's why we use transfer learning, because we don't have time, we don't have money to spend. So for example, Google spent so many, means a huge amount of investment for learning these models, such as CNN, such as VGG16, such as VGG16, ResNet, Inception. These are the models they have learned for you. So people can use it without spending too much time, right? And transfer learning and domain adaptation refer to the situation where what has been learned. So these are the two definitions. Both are saying the same thing, that the knowledge which we have learned for a different task can be used for similar but different tasks, right? So what Andrew next said, that we have supervised learning, we have unsupervised learning, we have reinforcement learning, but transfer learning is the next big thing in machine learning. So I would say to you guys who are working in machine learning, and especially in deep neural networks, that transfer learning is a good point for your research now, because it's developing. You can use it, you can extend it. A lot of research has been done into this, and if you want to discuss in detail with me, feel free to email, right? So this is the future of machine learning, I would say. There are different ways of doing transfer learning, right? There are three different ways of doing transfer learning. First way is you can use transfer learning as a feature extractor. Second, you can use it as a fine tuning, and third, as a pre-trained models. Pre-trained models. So let's start with the first one, ConvNet as a feature extractor. So what you are going to do, you have your own data set. So for example, Google trained something for cars and uploaded it into the internet, the model weights. You downloaded that weights, build the structure, and use that structure, right, to extract the features for your data set, right, and use their weights to classify. Second is fine tuning. What fine tuning do? That you use their network and weights and at the last layers of the neural network, you added your new network over there. So you are going to follow their protocols, how to extract the edges, how to extract this, how to extract this from the image. And then what you extract from there, you are going to learn your own model. So that means in first condition, you are using their pre-trained models, their model as a feature extractor. But in second, you are using their model as a feature extractor, but you are also learning your data. And in third case, you are doing nothing change in their model, you are using as it is. So let's go into detail. So ConvNet as a feature extractor, what we do, ConvNet pre-trained ImageNet remove the last. So if you see, this is the structure of the model. What we do, we keep everything up to here, up to the last. So you can see over here in this particular model, they have nearly 1000 classes, right? If I want to use it as a feature extractor, what I do, I use up to here, and instead of using their dense layer, which is over here, I'm going to add my own classifier, maybe a linear SVM or a softmax function. So you can see from input 1 to FC2, I'm going to use their network, but at the dense layer, which is the last layer, what I'm going to use, I'm not going to use over a neural network. I can use any kind of model which I want. This type of thing is known as transfer learning as a feature extractor. So that means you have used their model for feature extraction. Second point, fine tuning. So in fine tuning, we are not going to use up till this point. What we are going to do, we are going to use their network up to convolution blocks. So you can see here the convolution blocks ends. And here the fully connected neural network came. So you see after flattening, they have added fully connected layers over here, fully connected layers over here. So what you do, you use their model like this. And then on your data set, you are going to learn this. So that means up to above part, up from here to here, you are going to use their network, and here you are adding your own network to learn the weights, and then you will use it as a transfer learning model, right? So you use it as a fine tuning with the help of transfer learning model. So these are the two ways by which you can use the transfer learning. And third one is you don't change anything, you use their whole model as it is. So this is what we have, but I want to show you something else also. So I think I have stopped sharing my screen. So let me open something for you, and then I'll go back, browser. So, 1 second. Can you see my Chrome, guys? Anyone of you can answer. Google, can you see my browser? Hello, anyone can answer this, please? Anyone please unmute and tell me whether you can see my Google.
Yeah, we can see it. We can see it.
Thank you. So yes, so this is my GitHub. So let me show you. So I have an example for you. So these are my repositories. Last night I have created something for you. So you see, you can find all my codes over here, and you can do whatever you like. So let's open this to show you how transfer learning works, right? So this is your repository, which I have created for you guys. Feel free to play with it. I have created this repository in Colab. Colab, those who don't know what is Colab, Colab is an online Python platform, and it is free by Google. So those who have Gmail accounts or a Google account, they can use Colab for free, and they will provide you a free GPU which nearly cost Indian currency 3 lakh rupees for free to use. So I will show you how to use that. So either you can go and type Google Colab, right? And it will open, right? Like this. Or what I did, because I have created it on GitHub. So if I click over here, open in Colab, it will automatically open my notebook. That means my code into Python, online Python, right? So this is how the environments look. I have to write my codes over here and I can write it into the cloud, right? So I have already written it for you. Before doing anything, I have to connect to a virtual machine. That means once I press this connect button, what will happen? Google will allocate me a virtual machine over the cloud. So they will give me a machine over the cloud. Now in runtime, you see, you can change your runtime. I have currently selected GPU. You can see if you choose none, they will give you a CPU. If you choose GPU, they will give you a GPU. If you want TPU, they can give you TPU as well, right? So currently I have a GPU and I saved it. And this is my environment. So from the left hand side, you see, this is my working directory, right? Where all my data things. So what I did there, why I'm cloning this repository over here, because here I have a data which I will show you in a moment. So if I press over here, so sorry, first of all, see, there is nothing. If I refresh it, there is only sample data available. So if I clone my repository, run anyway, so it will clone. See, it's cloned, and now I refresh it. So you see the repository, the folder which is in my GitHub. So if you go in my GitHub, what I have cloned now, I will show you, is I have cloned my, this repository, right? So this is my repository where I have called data.zip, which I want to use. So I have cloned it and it came, and in unzipped it's dip. So you see it's over here. The whole things came. Here we have data.zip. So what I did, I want to unzip the data. So I said to Python that unzip the folder called data.zip, and how I know what is the path of it. So if you right click on data.zip, it says copy path. So if you copy path and just paste it over here, I will show you. So see, it's same, but you have to put it inside the quotes. So if I do that, it will unzip the data. So see, it's unzipping all the images. It's unzipped all the images, and it's a big thing. It's a big file. So I have to, come on, yes. So because it's occupying a lot of image. So what I'm going to space. So what I'm going to do, I'm going to do clear output. So it will only clear the output from here. It will not clear the output from the data. So if you see, a new folder data is created where there are 4 folders called human, cats, dog, horses, and each has an image of it, right? So if I click over here, if I open rider 1 and I double click on this, see a rider 1. So those guys who ride the bike, these are their images, right? And if I go to cats, you see there is a cat images, right? Like this. So that means these 2 things are done. So as I told you before, now I have a data in my path, which is fine. Now what I need to do, I need to install TensorFlow and Keras. So I said which version of a TensorFlow and Keras I want. So I said pip install TensorFlow and pip install Keras, and I run it. It will take just a minute maybe to install everything. Most of the things are already satisfied, so you don't need to install, because they give you everything pre-installed. But if you need a specific version, because I need a specific version, that's why I have written this. But otherwise you don't need to install anything. It's already installed. Most of the packages are already installed. So Yes, so it's successfully installed Keras, and you see it's successfully somewhere installed TensorFlow also. Yeah, so yeah, that's fine. So now I need to import packages which I'm going to use. I'm going to use NumPy, OS, time, in Keras. I want to use VGG16 model. Other functions which I'm going to use, so I have imported those all functions. It's all got imported. Right now see, I have written the code because the data is there in the data path. So I have to list, I have to see all my data. I have to slightly pre-process the data. I have to normalize the image. You can see I have rechanged the size of the image because each image is of different size. So I fixed the image of size 24 by 24. Most of the images are color. So they have 3 channels into it, right? And I have pre-processed the image and I put all the images into an array, right? So you see images of dataset horse, dataset dogs, dataset cat, dataset human. They are in the format 808 images. That means if you see, there are total 202 images for human, 202 images for dogs, 202 images for cat, and 202 images for horses. So in total 808 images, comma 1. So that means here the data was initially in 5-dimensional. I have reshaped the data into this shape because I want to get rid of 1 dimension. So what I did, I reshaped my data from this dimension to this dimension, and I put my data into this shape. So that means the first dimension is 808 images of size 224 of length, 224 of breadth, and 3, that means channels, that is RGB, that means red, green, and blue. I tell my model that I have total 4 classes because I have human, cats, dog, and horses, right? And I tell that because I have stored them inside the array. So I tell them that first 0 to 202 images are 0 class, second class is dog, third class is horse, and fourth class is human. So I tell them these because they are in array and stacked from 0 to 808. So I tell them, and I converted these variables into a 2 categorical because I have to fix the data like that. Then what I did, I random shuffled the data. You can see the data is randomly shuffled, right? And then I split my data into train and test size because the data is currently of size 808. So what I did, I have defined that the test size should be 20% of the data, right? So if I do that, you see now if I print, if I print over here, maybe x train dot shape, right? So if I see like this, come on, oh, it's taking too much of time. Yeah, so see my training size is 646 images. So that means if I press my test size, so is dot shape, so sorry, print right, and see, though the data is split into 2 parts. This part will be used for training and this part will be used for test. And what I did, I have used, so see, when I'm using it, a transfer learning model, I am saying that use the model name VGG16. So if I go to GitHub, not GitHub, sorry, Keras pre-trained models. So if you use Keras, so you go here and you see these are all the transfer learning models. So I'm using this model currently, right? So these are all pre-trained models trained on images, right? So if you want to use any of the model, these are all the models. I'm using this model, which look like this. These have the options. They have given you the codes. You can see in how to do this, right? So I've imported this. You can see that the weights are downloaded. The structure of the model is look like this, right? And these are the number of non-total parameters are this, and these are number of trainable parameters. So that means I have just in the above line, I have just imported the models. I have not done anything. Now, because I want to use my model as a fine-tuning model. So you remember, I hope you remember what is fine-tuning model. In fine-tuning model, I'm going to fix everything up to here, right? I'm going to fix everything from top to bottom. I'm not going to touch it from here to here. I'm going to change it from here to here, right? So see what I have done. I'm saying to my model that get layer block 5 pool. So where is block 5 pool? Here is block 5 pool, right? So I'm saying from top to here, get everything, right? And then after getting everything, flat it. So it will flat the model. And then what I'm saying, instead of training, instead of adding these number of layers, add 128 layers, because this model, why they have added 4096, because they have 1000 classes. I have only 4 classes, so I want 128 layers in my model. So I added 2 new layers, 128 here, 128 here, and I said the last dense layer should be 4. So instead of having 1000, I want it to be 4. So see, my number of classes are 4. That's why I have written over here. Now, if I run this, you see everything's remain the same up to here. Then after this, what I have added, that has changed. So we have I have added 128 over here. I have 128 over here. And my new classes are number of 4, which is different from above. Above they have 1000, 4096, 4096. I have changed their network, but only in the last 3 layers. And this is how you change your network, right? It is very easy. And then you have to compile this model. So I compiled the model, and after comparison, after compiling, so because I have just created the models, I have not compiled it. So once I compile the model, you can see here it says non-trainable parameters are 0. So that means if I'm going to train it, it's going to train the whole model. But here I compiled it. So what it's going to say, total parameter is this, trainable parameters are this, and non-trainable parameters are this. So that means if I use the transfer learning, instead of training these number of parameters, I have to only train these number of parameters. I'm not going to train this much with the help of transfer learning. And when I start training the model, it will take some time. It will take 10 to 15 minutes or 20 minutes to train, but I will leave. Meanwhile, I'll take your questions. It's going to train it, right? And this is how you're going to use it for your classification, right? So this is how it's do. And if you want to do this, replicate this example, go to my GitHub and my first repository. If you go to my page, you find repositories, and repositories, you'll see my first repository, which is known as GCRF transfer learning example. It's all running. You just click it over here and open it in your Colab, right? If you click it over here, it will open in Colab and you can run it, right? So yeah, that it is. And once it is done, I will come back. And in a meantime, I want to take your questions because we have nearly 20 minutes left. So guys, you are open to question, please, if you have. Hello. Any question, guys? Vishal. Hello, Vishal. Anyone, anyone question, please, guys. Feel free to discuss if you have. Otherwise, we have to sit quiet for, yes, Nidhini Patil. Nandini, sorry, Nandini. Nandini, please unmute yourself and ask question. Nandini. Okay, I can see Ankita. Ankita, do you want to ask anything? No. Hello, anyone? No question. There must be a lot of question, guys. You can ask anything if you want. Raise your hand if you want, please. Any question? I can see a private message from Siddhant that Colab is very good and you need something like this. Yes, it is very good. It is very good, Siddhant. And I would say I recommend everyone, those who are struggling. So for example, if you don't have a good laptop with a good GPU, I would say to you, please use Colab. It is very good. And if you want to learn Colab, go to my YouTube channel, which is called the Class of AI, which where we are uploading all your lectures. So the Class of AI, this is your YouTube channel. This is my YouTube channel, which I do. And if you go to the playlist, you can see I did it introduction to Python with Colab. So you can see how to use Colab and how to GitHub everything. Sir, how to install Keras? It is very easy. So you just write it like this. So it's already running. But if I can open, let me open a new one, maybe here. So Colab. So let me open a new Colab for you. Can you see my screen? Sunny, can you see my screen? Okay, good. So see, the Colab is now opening. So you just have to write exclamation mark, write pip install Keras. It will install. That's it. Just run it. So see, in front of you, it's running perfectly fine. It's installed. And if you want to check it is correctly installed, just write import Keras. If you press dot and press, sorry. So see, it's giving you the other options, all the objects from it. So that means, yes, it's installed correctly. Any other question? How to install Colab? Nidhini is asking how to install Colab. You don't need to install Colab. You just need a Google account. That's it. So if you have a Google account, free Google account, you can use it. So people are asking me to share my YouTube channel. So if you go to YouTube and YouTube, if you go and say the class of AI. I will share the class of AI without any space. It will come like this. And I'm going to share it in the chat with everyone. So if anyone wants, everyone in the meeting. Is that all right, guys?
So thank you, Haider, for the wonderful session.
Yes.
And,
I think one code is running
okay.
because I want to show them. Anyway, it's running. It will take time, guys, anyway. But once all the epoch will be finished, and you just click on this cell and you can see the plot. And it's fit very well. So currently you can see we are getting an accuracy of nearly 60%. As the epoch will increase, the accuracy will also increase. Right? And if you want to, one thing I want to show you more is once you do your code. So for example, I did my code and I want to save this code in my GitHub. So what you have to do, click on file, go to save a copy and go to here. It will open a window and it will, if you ask, it will ask you to sign into your GitHub. Once you sign into your GitHub, it will give you the number of repositories you have. So once you create your repository, I want to commit into my GCRF repository by the name demo fine tuning 1. So I already have demo fine tuning. I want demo fine tuning 1. I press OK and see it's done now. So it's done. So see, if I go into my repository again, previously it was demo fine tune 1. It is now demo 1. And if I click here and yes, and then I can open it in Colab directly. So I think there is Karthik. Can you explain how we can learn practical implementation of all shift you explained? I would say read my papers and email me. I can send you the codes. Or if you want to discuss with me, let's schedule a meeting. I can discuss with you. Is that all right, everyone?
I think if anyone wants to ask anything, you can directly unmute your mic and ask the question directly rather than typing it on the text box. Or you can raise your hand if you want. Ankita Shukla has raised hand.
Yes.
Ankita,
I have asked already. Ankita, I think she means, I don't know whether her mic is not working or whatever. So, and if you want to email, my email address is this, h.raza@sx. And this is my Gmail. And if you want, it's wrong. It's not ML. It's now I have changed the domain. So if you want to find my, want to contact me or my related information, it's sagihaider.com. So you find all the codes and everything, all my papers and everything over here.
So, okay. Thank you, Haider, for the wonderful session. I guess